Okay, mic check 1 2 1 2 1 2. Lowry, how's it going? We are working, yes. We are streaming, public, viewers. Yeah, nice. What's up, guys? What is up, guys? How's it going? Oh, how's it going, Doug? What are you doing? What are you doing? What are you doing on the stream? Hope you're doing good, buddy. Look at this massive chongus. You guys are going to enjoy this one. It's going to be a bit of a blast from the past, this one. Oh, I was wondering how you would do a repair while mid-stream. Eh? Got Steve, got two Steves in the chat. Hello Steve and hello Steve. What's everyone been up to this week then? Give me the rundown. Have you seen how long this freaking box is? Look at this. Absolute monster. Now, if you are a veteran watcher of the channel, you'll recognise exactly what this is as soon as it comes out of the box. Something that I used to have many moons ago. Not the exact one, but one of these models. And it's actually the amplifier that was used in, I think, my most viewed video of all time, which is currently on 1.6mm, which is like not that much for how long it's been on YouTube for, but it's still pretty cool. The old pioneers. What's up, Timbo? What are we working on today? Well, that is the question. That is the question. Here we go. Ah, someone actually decided to package it correctly this time. You've always got to have decent padding on the either end. I mean, a little bit of bubble wrap could be better, but yeah. So many times I get stuff come in where it's just like the cardboard from the packaging is right up against this and all this stuff gets bent, the terminals get pushed in, absolute disaster. Right, I've got a little note on the amplifier here. Let's just see what it says. Hopefully it's got no, just double check it's got no personal details on it before I show it to the camera. Let's have a look. What does it say? Okay, so we've got some personal details on there. But it says, if I fold it over, no output on channel 2. Alright, so this is a 2-channel amplifier, as you might have guessed. Let's get it on the bench. This thing generally isn't really worth repairing most of the time. But we have the loudest.com TL1021. The old school beast. The unnecessarily oversized 2 amplifiers crammed into 1 heatsink jobby that I actually used to run back in the day. Well, what's going on with this? This light usually isn't in the way of the camera, so why is it in the way of the camera today? What has changed about my setup? It doesn't usually interfere. Oh, that's a bit better. There we go. Then we've got the multimeter cam. Just need to realign that now. There we go. That'll do. How are we doing tonight, Matt? How's it going, buddy? Please fix me. Oh man, I don't know if you can still get parts, Doug. Right, so for those of you that haven't seen inside one of these before, you're in for a nice surprise. Everyone recognises this amplifier, surely. Tell me you recognise this amplifier, guys. Who had one of these? Who has owned one of these before? Although, were they only a UK thing? Ah, maybe they might have actually only been a UK thing. I'm not even sure. Guys, tell me if you had these in the States or not. Loudest.com brand. They definitely sold these boards in the States under different brands, but I'm just curious if you had the loudest.com brand or not. Never seen one in Sweden? Never seen one. Oh wow, so guys, in for a bit of a surprise then. Never seen this brand, says Larry. Okay, not to my knowledge. Oh right, okay, wow. Fair enough. You'll definitely, if you know a little bit about amplifier guts, if you recognise common circuit board layouts, you'll definitely recognise the layout, or the layouts of this. But yeah. Once we finally get back off, with about 1 million screws, there's something rattling around in this as well. Okay, so back's coming off. What do you think you're going to see? We're going to see... Okay, so does anyone recognise that board layout? That's probably one of the most used board layouts in the history of car amplifiers. So if you don't recognise that, where you been? But yeah, this company basically just crammed 2 of them side by side in the same heatsink. So it's a 2-channel or dual mono. Actually, technically it's a dual mono, because each channel has its own power supply, which is what defines a dual mono. So this is basically a dual mono. Interestingly, the guy actually said channel 2 doesn't work, but looking at this, woohoo! Looking at this, we've got I think more than just channel 2 with problems. Right, I'm going to give you this zoom in cam. Let's take a peek at what we've got. So quick visual inspection then. We've got some bullshit over here. So this is output section for, I'm going to call this channel 1. Channel 1 on the right hand side here. So clearly we've got bye-bye output FETs on channel 1. That's unusual. You don't usually see it that bad. You don't usually see it burned this bad on the output side. Often it's the power supply side that does this, but that means the fact that you've got this amount of burning and stuff on the output side means that high voltage and high current was available for quite a long time, which usually isn't the case. Because as soon as there becomes a problem, the power supply shuts down, so you get burned power supply because it has 12 volts across it, but not usually output side like this. And then, okay, so that's on this side. We've also got another burned one over that side. So this is the other side of the board. We've got another visibly burned one. So that's kind of uncommon to see on the output sides. If we take a look over at the other board has similar shenanigans, but over in the power supply section. 18 years since I've seen one of these, says Doug. 18 years. That's well, yeah, I had one in 2010. So yeah, about 14 years ago. And they weren't new then. They were pretty old then as well. Steve says, have one of those currently working on, power supply blow up. Fair play. They're quite susceptible to vibration damage, these. The inductors, transformers, actually this one, there's been a few revisions of these. The earlier ones had extremely loose toroids, but this one, I think, is a slightly later one. They're actually seated down a fair bit better on this. But the guy said that one of the channels was working. Maybe this channel was working, this one over here, because, well, no visual damage on the output side. This power supply FET looks like, oh no, you know what it is? Dude, my man, someone's repaired this, but done like a sketch job. What's that all about? So basically, this has been repaired, in inverted commas. We have the original FETs from factory here. Okay, so these are P60NF06. And then I assume that at some point this FET had died, because Big Man has soldered on to the old legs this one, which is a P80NF100, completely different model of MOSFET, has just slapped that in place in parallel with all the originals. So Yeah, interesting. So we're going to assume that this is what the guy is calling channel 1. This side is probably working. I mean, that being there isn't going to stop it working, provided all the other FETs are okay, obviously. But it's very bad practice because it will the current sharing won't be equal amongst these. I wonder if I can get away with... You see, the problem is, now that that's there, what am I going to do? I'm probably just going to have to replace all the power supply FETs on this side, even though all these are obviously working fine, these original ones, because I won't have a matching batch for that, which is annoying. Unless I just leave it as it is, like I could say to the customer, look, this is really bad practice, and this is like the completely wrong part, someone's just freaking hacked in there, but it will save him on the repair bill if I don't touch that. Anyway, let's turn our attention to the one that's got obvious, like, actual problems that was going to prevent it from playing, this side over here. So what I'm going to do is I'm going to get this out of the heatsink, because it's definitely going to be an out of heatsink job with that board looking like that. And let's go from there. Where do you source 3300 microfarad 100 volt capacitors? Just from your, just from your usual reputable electronics supplier. So if you're in the States, probably DigiKey or Mouser maybe. For me in the UK, I source them from Farnell or RS Components or Mercatio. So yeah, we're going to just get this out of the heatsink first and then see what's going on. Ah, interesting as well. Yo, what's going on with this? This has had the rail caps replaced as well, but like, what? See here? So these are the original rail caps, okay? So we've had replacement caps put in, 100 volt, 2200 microfarad. They are zip tied together, wobbly as anything. Not even soldered to the top of the board properly by the looks of things. I wonder whether that's why the output section failed. These aren't actually part of the board, and the one of these rails, which is possibly going to be a positive rail, has not had any filtering for the rectification side. What? Someone's gone ham on this. Let's take that off. Dude, what's going on? Actually, you know what? I think that is actually soldered to the top of the board. It's just like someone's done some next job on that. The legs are like kind of the legs are heat shrunk and soldered just to the top of the board. Yeah, I reckon someone's done that without taking the whole board out. The reason that someone's done that is to prevent having to take the whole board out of the heatsink. That's sketchy, bro. Right, we're going to sort that out. I've got some identical spare caps for these, so we're going to replace those with originals, because that is like, I mean, that's just going to freaking fall off, isn't it? Box that up and give it back. Now, trust me, I did say to this guy, I was like, look, are you sure? Are you sure you want to get this repaired? I think these things are only worth like, I don't know, I think I've seen them generally sell for like 120 on the used market over here in the UK. I mean, they're a bit big for what they are. I mean, you can get 3000 watts in like a tiny package now. So for 3K, they're monstrously oversized, but they are 3K at 2 ohm because it's two boards bridged basically, so it's going to give you the power at 2 ohm. So if you just need 3K at 2 ohm for whatever reason, then these are actually still an okay-ish buy if you can get them really cheap for like 100, 120 pounds. To get 3 kilowatts at 2 ohms for like under 150 quid is actually like quite decent. So they do still make sense to some people. But yeah, how's everyone's week been so far? Tell me what you guys have been up to. Oh man, these screws are tight. I did actually get my new phone. You remember, if anyone was chilling with us on the last live stream we did, I was looking at getting a new phone, hey, and you guys were giving me some advice, telling me your thoughts. I did actually go with the Xperia 5 Mark V in the end. Really happy with it. It's pretty dope. See if I can open something that doesn't have any personal information on it. No, I don't think I can, but yeah, it's really actually this nice blue colour. It's like super nice. One of the best cameras as well that I've come across on a phone. It's not a point and shoot. It's not. It doesn't flatter your bad photography. It is like an actual camera. It's like having a digital camera in your pocket. So it's like a Sony camera in your pocket. So it doesn't just take like you can't just point and shoot and like expect amazing photos like you can from an iPhone or like a Pixel 8 or something like that. You actually have to kind of know a bit about what you're doing and set it up correctly to get good results. But the results that you will get will look way better than any AI enhanced bullshit from a Pixel 8 or whatever. I like the form factor of it as well. I don't have the biggest hands in the world. So a lot of modern phones are like massive, and I need to be able to. I really want to be able to use my phone with one hand, you know. And so many of the phones that I was looking at, I would really struggle to stretch from one side of the screen to the other with one hand, and to comfortably hold and use in one hand. Whereas the 5 Mark V is like really slim. It's actually slightly slimmer than my old HTC U12. To the point where my old HTC had 5 icons wide on the screen, 5 app icons wide on the screen. This one actually only has 4, which is a bit of a bummer. I'll be like, oh damn, but it's taller, so I can get more height-wise. So it kind of works out. All right, are we ready to come out then, my friend? Yep, I think we are. Got a little bit of electrical tape here to remove. There we go. Okay, so what we're going to do to work on this, I think, is just kind of fold it over on itself. That's what we usually do. Oh man, what is it at the moment recently with getting amps that have been on fire with like massive holes in the board? We've had like, this is the 3rd one in like the last month or something. You don't get any like this for like years, and then they all come at once. This really isn't that common. There's something about like recently. Just got loads of these that have got massive holes in the board. Sheesh. Fortunately, there's not. I don't think there's any real critical traces or anything on this side. It's literally just a rail, like a large rail trace. I should have brought the vacuum cleaner. To be fair, I wasn't expecting this to be like this, so I should have brought the vacuum. 13 BTRX, enjoying my days off. I go back on Saturday. Oh, what a day to go back. Remember you mod the audio pipe, release part 2, you still working on it? It's one of them projects that I didn't really get stuck on. I need to wind the transformer, okay, for the power supply side. And I was kind of like umming and ahhing about what kind of wire to use on the secondary of the transformer, because I was originally going to use Litz wire, but then I realised that that's stupidly overkill and is absolutely unnecessary and would just make it way more expensive and complicated for no real benefit. So then I was like, oh well, I guess I need to order some some wire then, some copper wind, copper strand cable. And then I just kept putting it off. I never ordered it, and I was like, oh, I've got to work out how long I need and how thick I need it to be. And I needed to do like a bunch of calculations to work out how many strands I'd need, and I just kind of kept putting it off and putting it off and putting it off. And because I put it off for so long, it's now kind of just on the back burner, like in the back of my mind. And I have a bit of an ADHD block on it. I don't know if you ever get that, if you sort of struggle with something. Sometimes you can have a project that's really fun and that you're really enjoying, but once you've been working on it for a while, especially if you kind of not hit a roadblock, but if you hit a point in it that requires quite a bit of effort for not much reward, sometimes it can be really hard to like drive past through that kind of like annoying bit to then get a result. I just kind of got a bit of a mental block on it. Every time I look at it, I'm like, oh, I'll do that later. and it's kind of been like that for like a year. So I will finish it. I've been getting a little bit of background motivation for it recently, so I will finish it, but it's just one of them projects that became a little bit more complicated than originally planned, and then I got busy, so I put it on the back burner. And now because it's been so long, it kind of feels like I've forgotten a lot about it. I work 2 weeks on, 2 weeks off. That's pretty sweet. That's not a bad way. But are your 2 weeks on, are they like very intense? Is it worth it? New main camera settings or lighting. Yeah, the camera looks different, doesn't it? I think maybe I just changed the white balance setting. This Canon camera, I was using it actually as a camera, not as a webcam, last week or this week. So I actually had it. So I probably changed the white balance settings. That's probably why it looks different. Alright, yeah, got a little hole there, but nothing we can't work with. That's fine. Seen much worse in my time. Is the purpose of trying to repair fire damaged amps to salvage parts or combine amps together? Well, like, basic fire damage isn't like the end of the world, really. Like, everything's repairable. So if it's got fire damage like this, got a hole in the board, well, okay, big deal, no worries. You just have to reconnect the traces that have disappeared. Yeah, not too much of a big deal. Ones like the Sundown that have got a massive hole in the board, typically those ones, and also where like a lot of the high current traces have disappeared as well. Yeah, you can reconnect, like that's totally repairable. That Sundown we looked at the other night that had a massive, like half the board taken out of it. The guy actually still wants me to go ahead and repair it, or try and repair it. So I probably will be repairing it at some point. I'll probably do it on a stream. I've said to him it's gonna be like a really expensive repair, and there's absolutely no warranty on it. And I can't guarantee it's not gonna like blow up again in like a week, because there could be all sorts of things going on in the middle of the board where a little bit more of it's carbonized or whatever, or I don't know, all sorts of whatever. The trace positions as well will be different, where we're having to rebuild the traces, and they might cause interferences, especially where there's high frequency pulses going on. We might not get the trace lengths and the pathways like exactly perfect for the circuit to be happy. We'll try our best, but at the end of the day, it's going to be some cobbled together mismatch of like jumped traces and like parts screwed to the heatsink with wires coming off them. It's going to look a mess. I said to him, there's absolutely no guarantee on that at all. But I can make it work again for you, but I don't know if it will be working, for the amount of time it would be if it was new. But like with something like this, where it's got a bit of a hole in the board, like the guy wants me to repair this. I want to get the repair money for it. It's not too much of a big deal. It's just, all we've got to do is just jump from here to here with a bit of wire. It looks bad, but it's not bad. It's not that bad. As long as you get rid of all the carbonized PCB and you connect up all the traces again where they're supposed to go, then you're good to go. And the beauty as well of this being like a cheap car amp is that it's only a dual-sided PCB. So if this was like a computer graphics card or something where the PCB is like 12 layers deep, yeah, you probably don't want to be like spending your time on that, because again, while that's totally repairable and there are videos of people repairing them, it's just so much more work. Mark, yo, what's up? Finally caught alive. That comment threw me a bit there. Finally caught alive. I think you meant to say caught alive. In the Sound Digital 3000.1 output marked as A3, can we use our 4127? Yeah, that's probably alright. Although in the 3K, you're probably better using an IRFB 4115. In 3K, the rail voltage will be like under 150 volts, like quite a bit under 150, probably like 120 at tops. A 4115 is a better part to use. but if the rail voltage is a bit close to 150, then you could drop in an IRFB 4227. The 4127s I'm actually not a big fan of. Have a look at the datasheet for the 4127s. The actual area of safe operation graph is pretty poor. They only really have high current capabilities at super low voltages, and as soon as you go above like 100 volts, the current capability just drops like a rock. I'm not a huge fan of those FETs. So stick with 4115s or 4227s and you'll be fine. You could also use some 61N20s. They'd be fine as well. They're a bit slow though, so you have to be careful in high speed class D switching. I need to replace some 3120s. Have you ever dealt with these? Sounds like you might be repairing a really old janky discrete class D. Typically, like, you know, the SSL Evo and the Boss audio stuff, like really old discrete class D circuits typically have used those FETs, and they're very fussy actually about the FETs you replace with. They have to be the right gate capacitance for the drive circuit because it's all discrete. It doesn't have, there's no tolerance for like differences, you know, variances in there. So I think in the past I've had good success using 38N20. I think it's FDA 38N20. Also 42N20 I think I've seen in a couple of those style of circuits, so they obviously work fine as well. But yeah, I would say try 38N20, which seems to be a part that has worked in the past for me, if I remember rightly. Alright, let's grab my pliers, let's cut it. So we've got the, oops, wrong screen, sorry, we've got the carbonized board mostly cut away there. This film capacitor here, this is toast. It's actually, I mean, actually it's probably fine internally. It looks a bit melted, but it's just a plastic casing. We're going to leave it there to see how it goes actually. Fuck it, why not? Over this side, we are going to need to rebuild traces for the gate path and the gate resistors. That's easy, no problem. We want all new output FETs, obviously. So let's just start cutting these out. It just makes it a little bit easier. I wonder if the drive circuits survive. Now usually these circuits are actually great circuits to learn amplifier repair on. And the reason for that is generally they are very simple repairs, because the only things that ever really die in them are output FETs, gate resistors, and then these three little transistors. And these are a 2T and a pair of 2Xs. The reason that the rest of the drive circuit, like on this driver card, doesn't get hurt is thanks to this optocoupler. So this optocoupler is electrically isolating the rest of the output drive circuit from the drive PWM generation circuit here. An optocoupler is just a component that couples two circuits together without an electrical connection. It's done optically, optocoupler. So basically there's like a little LED inside that package there, and a kind of receiver, and that's how the signals get passed through from one side of the optocoupler to the other. So signals can get through, but any high voltage DC or current can't actually get through. Current can't pass through the optocoupler. Only signals can pass through the optocoupler, logic signals. So that's pretty cool. So any nonsense that goes on with the output section when these amplifiers fail, like high voltage DC spiking back down from the FETs, killing these drivers, once it gets to the optocoupler, it can't make its way further back to the drive circuit because the optocoupler just blocks it. So they're really good amps to learn repair on because they're typically very simple to repair and not much else goes wrong with them other than FETs, gates, drivers, and that's it. Kind of gets you into the swing of repairing and gets you used to soldering, and you know, just gives you experience without really having to think too hard about nonsense that goes on with other Class D circuits. Zach says phototransistor. Yes, phototransistor, optocoupler. Pronounced it very well. John says, yo, staring out the window, waiting on FedEx to bring my Salt 8. Exciting times, my friend. I hope it treats you well. I am not a big fan of the Salt range of amplifiers, but that's mainly because, that's not because they're a bad circuit. Really, they're actually quite a decent circuit. I just don't think they're very good value for money. They're like, the markup on them is extortionate. They're so expensive for what they are, and you could get like 4 times the power with still a very good circuit design for the same price. But if you can afford it, and you like the brand and you like the branding and you like, you know, Sundown, you want to keep everything the same, then by all means, enjoy, my friend. I hope it treats you well. Try not to kill it. They're very expensive to repair. Man, there's no thermal mass in this PCB at all. These are just coming out like instantly. It's not like working on a JL Audio HD series or something where you've got to blast a hot air gun at it at the same time as you've got your iron stuck on it. Has anyone else in here ever tried working on a JL Audio HD amplifier? My God, them boards, they just soak up whatever heat you throw at them. It's super hard to get things soldered and desoldered on those boards, especially if it's connected to like a rail or ground trace. Fortunately, whatever happened over here on the output side didn't kill the power supply, which usually is what happens. The fact that we've got a fire that happened actually over here on the output section suggests that when the output MOSFETs over here shorted, they actually shorted to a high enough resistance that was high enough that it didn't overload the power supply section in terms of current. But obviously with it still being a relatively low resistance short, it just turned into a heater, like a little heating element, which is why we've got this fire on the PCB. But usually when the output FET's short, they go low enough resistance that it just completely overloads the power supply FETs. Either that or it blows your inline fuse or something along the line. But yeah, this is a slightly more rare occasion where the MOSFET shorted to a high enough resistance that the power supply just kept on giving them pulses and building that high rail voltage which has caused the fire. Come on, come on, actually come. Why am I doing this from the top of the board anyway? I could be doing this from the bottom, but I started now, so I'll finish. I'll flip it over to get rid of the solder from the holes. John says, I'm running headway, so the rating's at 12 volt is what I'm looking for. See, that's how they get you. You're the perfect customer. See, the thing is, it's not important where the manufacturer rates the amplifier. Like, the fact that Sundown have rated their amplifiers at 12 volts doesn't mean that those amplifiers are any better or worse running 12 volts than any other amplifier. It's just the point at which you declare the power rating. It doesn't mean that other amplifiers that have their power ratings at 14 volts are any worse performing at 12 volts. It doesn't mean that at all. All these car amplifiers, all these Korean circuit designs will operate perfectly from generally 9.5 volts up to like 16 volts. They'll operate perfectly in that bandwidth. The only thing that changes is the amount of power that the amplifier makes going up the voltage range, because the output rail voltage is directly proportionate to the input supply voltage. So let's say you've got an amplifier that's rated for 5.5 kilowatts at 14 volts. Well, it's identical to an amplifier rated 3 kilowatts at 12 volts. They're the same amplifier, just one manufacturer has decided to give its power rating at 12 volts to entice people in that are thinking, oh yeah, I want an amplifier that's stable at 12 volts, whereas actually it would be exactly the same experience buying the amplifier rated 5.5 kilowatts at 14 volts. They're the same amplifier, just the two different ways of marketing them. But that's how Sundown have marketed the salt amplifiers, Sundown low voltage technology. It's not low voltage technology, it's just that they've decided to market the amplifiers based on the 12 volt rating rather than based on what they make at 14 volt. And they haven't done anything special to make them any more stable or anything at 12 volts. All car amplifiers are perfectly stable at 12 volts, perfectly happy, no problem at all. Easy days. there's a bit of a myth about holding 14 volts. If anything, the amplifiers actually last less long. They actually don't last as long at 14 volts, but we won't get into that now. So a couple of traces there we've got to rebuild, as you can clearly see. No worries. I love the way the quality check passes right by where the fire is. Yeah, that's funny. Although the quality check was probably done in the late 90s or the early 2000s on this amplifier, I imagine. Now back in the 90s, all the cheetah amps were, oh wow, that's just so, all the cheetah amps were amplifiers that were rated 12 volts, 4 ohm, and they claimed that they could only play down to 4 ohm, but realistically they were designed to play down to 1 ohm, basically quadrupling the power. So you'd enter your competition with an amplifier supposedly rated like, I don't know, 50 watts at 4 ohms, whereas down at 1 ohm it was doing like 250, 300, 400, or maybe more. Probably more actually, because the 50 watts is probably a conservative rating. So it was probably rated 50 watts, 4 and 12 volts. And by the time you got it onto 14 volts, plus the you know, the actual power it was probably making 100 watts. And so then it was probably making like 500 watts at 1 ohm, 14 volts. Whoa, bringing that one back from the dead. There's the hole in the board, yeah? There's another hole. I was going to say, I was saying earlier, it seems to be a bit of a weird month for boards with holes in them. It's not that common, really, to be honest. But for some reason, at the moment, it seems to be a bit of a surge on those. Alright, so we have all the solder sucked from the holes. Excellent. Make sure there's no solder bridges, and I imagine we're probably going to need new drivers in this, but I'm curious to check them out anyway. So let's flip this back over the correct way around. Let's just do a quick multimeter check on the drivers. It doesn't always tell you the full story, but if they're really badly dead, then it will tell us a bit. So on the PNP, driver, what are we saying? We got 627, 648. Flip the probes. And okay. That might actually be alright on the PNP. PNP is usually the one to die first. Yeah, that kind of looks alright. As long as we get sort of 500 or 600 this way round, yeah. Okay. Maybe the drivers survived. Maybe the short was kind of intense and it just grounded all of the voltage, so none really spiked back to the drive circuit. So we might actually get away with original drivers in here. Flip the probes. Yeah, might actually get away with original drivers. And one good telltale sign as to whether your drive circuit is likely to be okay or not is whether the gate resistors survived. If all the gate resistors are okay, This one's open, so some current did make its way back to the drive circuit because that gate resistor's open. That one's okay. That one's okay. So we've got one open gate resistor there. And then who knows what the bloody hell happened to these ones because they are gone. But let's just check the other ones that are left. That one's alright. That one's alright. I know it says 17 on the meter, just ignore that. It's because it's in diode mode. So it always reads a little higher in diode mode than it does in resistance mode. But I know that 17 on diode equals 10 on resistance. So, okie dokie, no problemo. Oh, this is another gate resistor actually. Just happened to... Oh look, there's a 10 ohm gate that survived, like just chilling in the middle of nowhere on this little island in the middle of this hole. That's hilarious. Okay, no worries. Well, obviously we can't use that, but it's funny that it's still there. 100, and we should have a 103 pull down resistor and this diode as well. Is that diode okay? Yeah, she's fine. Excellent, no worries. So, ladies and gents, what I'm going to do is power this side of the board up, and we're going to see if we get pulses, see if we get drive pulses on the FET locations here. If I can remember how to power one side of these up at a time, because although they are separate boards, they do kind of have the remotes linked. Do you have customers sign some type of waiver so that they don't come back to you if it catches on fire or destroys property? I don't, but like maybe I should. Like the UK isn't as bad for that. I know that in America it's like you get sued for anything and everyone's trying to sue each other at the easiest possibility. But yeah, I don't know. Maybe I should think about that. Like it's not a stupid thing to think about at the end of the day, is it? Like if I repair an amplifier for someone and, you know, a couple of months down the line or something, something catches fire in their car and it looks like it might be in the amp or whatever. Once something's been on fire and their car's burnt down, it's going to be impossible to really tell whether there was something wrong with the repair I did that caused the fire, or if it was even the amplifier that caused the fire in the first place. These things are really hard to tell. But I would definitely wouldn't want like the implications of that. So yeah, it might not be a bad idea to actually up the sort of legalities in that sense, and just have some kind of waiver whereby, you know, just to put it out there, like that's never happened before. Typically my repairs are pretty good. I don't usually get stuff come back, or if it does come back, it's usually just something really stupid that has failed in between, failed after like endurance testing, that was like on its way out but that didn't show up during endurance testing or something like that. But yeah, it's not very common, to be honest. If it was common, then this business wouldn't be viable, put it that way. It doesn't make much money as it is. Good old Type 4 board, yep, the old Perry's. Oh, one thing about Perry Babin's guide, I need to go through actually. I want to do a live stream going through the updates to Perry's guide and just see what kind of stuff he's updated it with, and just share my thoughts on his revisions. Be really cool stream. Ah, thanks is for a 5, my man. Thank you very much, buddy. That's super kind of you. $5, that'll do me a nice cheeky bottle of wine. My top tip of the month, 2 drops of 3-in-1 oil on the plunger part of the solder sucker. Yo! Oh, equals turbo time sucking. Now, wait. 5 minimum super chat. I have no idea about that. I don't set the super chat limits. I thought that you could just donate €1 or $1 or £1 on the super chats. Like, but I've no idea. I don't use super chat. I don't have much time to watch lives on YouTube, so I don't like watch stuff or donate on lives. So I have no idea how that works. But yeah, is 5 the lowest now? That seems like quite a lot. You used to be able to just donate like $1 or something. I wish he would add a Xenon section to the guide. I think what he does, like I think it's the Xenon boards are type. Well, I can't remember what number. It's been such a long time since I looked at Perry's guide, like years ago. I'm pretty sure one of the generic Class Ds is like the typical Xenon board, but I want to make a version of Perry's guide in video form. Guys, alright, real talk now, real talk. Would any of you be interested in some form of amplifier repair guide in video format, but like easy to digest, like 2 or 3 minute video clips, really going into explaining each individual part of the amplifier circuits, a bit like how Perry's guide does, but in video format, so you can actually see everything going on. But it would obviously be like paid. It would be like Perry's guide. So it'd probably be like a Patreon or something like that. So I'd make a Patreon account, and it would be like however much per month, or maybe it'd be a one-off price or something, because otherwise people could just like pay for the one-off thing, download all the videos, and they bugger off. So it'd either be like a one-off thing for the entire guide, and it would be like gigabytes and gigabytes and gigabytes worth of video guides set out like Perry's guide, but with all of the more recent circuitry and the tips and tricks that I have learned myself that I think will a lot of times be a bit more useful than some of the stuff that Perry, like Perry's awesome, but a lot of his methods are a little bit outdated for the newer amps. So I want to kind of really do a super in-depth guide. Like my videos are fine, and if you watch through all my live streams and stuff, you can pick up all of the content there anyway, but it's just a bit more difficult to like have to navigate through, because I do all this talking nonsense like I'm doing now, and you know, the amplifier that comes in is just the amplifier that comes in, rather than me like hand-picking, cherry-picking stuff to work on. But I'll have to obviously work out how much would be a reasonable price to ask. I think Perry's guide is like $50 or something like that. So I might ask a little bit more, just because times have moved on a bit and it'll be all in video format. Yeah, not sure. But let me know if you guys think that would be something you'd be interested in. Most people are saying yes. That's because you guys are repair enthusiasts in the old live chat. I know that a lot of people watch my live streams and watch my videos just for entertainment. They're not looking to repair amps themselves, and wouldn't really be interested in that. But I know a lot of people are interested in repairing amps. Yeah, let me just scroll up a bit. It's kind of scrolling. Oh, yo, Nux sends me $1, so you can still do that. Okay, awesome. Thank you very much for the buck, Nux. Appreciate you. Thank you very much. And I'll have to give that a go, actually. Actually, you know what? I do have some 3-in-1. Should we give you a little top tip a go? Look, I've got some 3-in-1 here. I think it's got some pressure left in it. So let's open up the old solder sucker. Just gonna, so open the old solder sucker up, and let's just drop some oil in there and just see. Let's just get a benchmark. How quick is it at the moment without the oil? I need a new one of these actually. It's the button is a bit fucked. So at the moment it's like, it's pretty powerful, to be fair. Like it does have some speed to it still. You can see it kind of recoil. So let's just compare that. If I spray some 60-40, not 60-40, sorry, some 3-in-1. I'm so used to saying 60-40 because of the... Oh, that would explain a little bit about what's going on with this. That has come away from the rubber. I need to glue that in or something, or bend it out maybe. Maybe if I bend it out, I don't know. I'll try and bend it out a little bit. These things are so cheap, but this one I think has lasted me like 2 or 3 years now. It's lasted me a long time, this one. These things are so cheap, it's even worth buying a new one like every few months if you need to, but I think this one's lasted me like quite a long time. And they just work, you know. Simplicity. Sometimes the simple solution is the way. They just work. Alright, so you're saying drop some 3-in-1 down there and around the rubber seal? Okay. Yeah, there's no pressure left in this. Like there's loads left in it, but there's no pressure left. So it's just gonna kind of drip out, I think. Yeah. Okay, that's coated in there. Let's just whack a few drips in there. Why is that? Why is it that there's loads of oil left in this, but the pressure's gone? I didn't think that could happen. Oh, that feels a lot smoother already. Yo. Alright. Oh wait, where's my spring? Oh, guys. I forgot to put the spring back in. I was like, what's going on? What are we saying? So yeah, most people are saying, yeah, that would be cool. I'd recommend making a separate channel for that, so it becomes essentially a video book with chapters. Yeah, either that, or I was thinking of doing it as a YouTube membership. So the choices that I've got for that, the options that I've got is either a Patreon, a YouTube memberships thing, or just a one-off paid download like Perry's guide, like a Google Drive, Google thing or something. Or like a Mediafire, you know, or WeTransfer. Yeah, it might be like a WeTransfer or something like that, just a one-off big-ass download. I feel like a one-off big-ass download might be better, It'd be better initially because it would be like I'd be able to charge the full amount of what the guide's worth in one hit, so that then the inrush of people buying it would be like quite decent for me. But the Patreon or the YouTube memberships thing would have the benefit of the recurring monthly payments from people that just want all the updates, because obviously even once I finish the guide I'm still going to be learning new things, and there's still going to be new circuits coming out and that I want to add to. So maybe a Patreon or a YouTube memberships thing would be better for that. I don't know. I'll have a think about it. Thanks, Damin, for the 2. Oh, thank you very much, my friend. You've spent enough money with me as it is on that small 5. You don't have to donate anything, my friend. But thank you very much, man. I appreciate that. It's got a little cat emoji there. Can you make that bigger? I can't believe that they charge you £2 for this little animated sticker, but you can't make it any bigger. Like, you want that to fill the screen, don't you? Oops. But thank you very much, Damin. Appreciate you, as always. Equipment needed and recommended. Yeah, that will be one of the videos for sure. If you could use the guide to repair 1 amp, it would pay for itself. Yeah, exactly. That would be what I'd be hoping for it to go through. Like, you know, a bit like how I did. So guys, I recently released a video on exactly how to repair a Sundown SFB 5K. Like, that video is an hour long. That's for free. You guys just get that for free. You could now take a blown Sundown SFB 5K with the tools that I outlined in the start of the video. You could repair that, and that's for free. So the videos would be like probably similar to that, going over each amplifier style. So if you like the Sundown SFB video, then maybe you'd like what I have planned. Thank you very much, Audio Mess. Greetings from another long-term subscriber. 10 years, bloody hell. 10 years. What was I doing 10 years ago? 2014. I probably had the Zions 15s or something around that sort of time. Wow. Thanks for sticking with me for so long, man. Appreciate you. That's really kind. Thank you so much for the 5. That's really, really, really generous, buddy. And we've got a 420. Hey. What sticker is that? Number 1. Sam and Prepare School. Okay, well, you guys seem pretty gassed about that, so I'll check it out. Perhaps a Discord with separate rooms. That might work. Yeah, I've never really been super into Discord, but it could work. Recharge the spray can with air. How do you do that? Do you like spray air in it somehow? It's pretty cool if you can. The propellant gas is evaporated over time due to a leaky valve. Ah, makes sense. The cat is stupid. You get the £2 right. Yeah, I pretty much get the £2. YouTube takes a cut, so I think I'll get like £1.70 from it or something like that. YouTube does take a cut from the donations. So if someone donates like 20 or something, I get like, man, maybe like 16 or 15, or I don't know, it might even be less. One question: head units have yellow power wire and red accessory trigger wire. Power is pulled by the yellow or the red? So power is pulled through the yellow. The red wire is literally just a logic level signal to come on or off. So you'll notice that the yellow wire is always generally thicker than the red wire. So yeah, all the power is pulled through the yellow. Spray can air filling adapter. Sweet. I will check it out. Anyway, let's see whether this is turbocharged now with the old oil in there. Let's see. It kind of feels the same, not gonna lie. Not gonna lie, in this instance with my one, kind of feels the same, but appreciate the tip, and that probably definitely will help out if someone's got a one that's a bit sticky or a bit slow. Anyway, so there, let's get some power into this bad boy, shall we? Let's turn the supply on, turn the scope on for the first time this evening. Going to keep the rail voltage nice and low, 9.5 volts to start with, as always, guys. You know how we roll. Get the remote plugged in as well. Okay, so hopefully there's no shorts on the rails, and I haven't taken these janky capacitors out yet, and I'm just going to leave them in there for now because they are actually soldered correctly to the board. So I'm just going to leave those in for now. Just going to make sure we get some power supply PWM. Actually, we're not getting... Oh, that's strange. Is there a fuse missing? We've got 12 volts going in at the terminal, but we don't have 12 volts on the back of the power supply FET. location. Okay, why is that? Because this first board should just have straight continuity to... Oh, there we go. We've got it coming into the bloody transformer. So we should have it coming out of the transformer. Well, it coming into the primary, coming out of the primary, but not going in, not on the back of the FETs. That's strange. That's very unusual. So basically the way these work, guys, for anyone who doesn't know, 12 volts comes in on the terminal here, on the power supply terminal, and then the first place it goes is to the transformer primary. So it sits on the transformer primary, and it goes whee through the primary, and then the exit of the primary sits on the power supply MOSFET drain, and then the power supply MOSFET switches that 12 volts to ground through the transformer, creating this oscillation. So somewhere there's a break between the power supply, transformer, primary output, and the MOSFET drain on both sides. Oh wait, we got it on that one. I think actually that the power supply did fail, just doesn't look like it. I think that all of the traces on the underside are fused open. Yeah, look, they're all shorted. They're all shorted. That's unusual. Usually when you have a dead power supply like that, all of the power supply FETs will be visibly burned, but from a visual inspection looks absolutely minty. And there's no short across the terminals either, because all of the bloody traces are fused open on the back side. Check that out. Let's have a look. Let's see if we're right. Well, we must be right, because there was definitely no continuity. Oh yeah, very small fused. So basically, guys, this board has built-in fuses for each FET, unintentionally. The unintentional fuse. Zoom right in. You can see that. Zoom out a little bit. There we go. So every single one of these has a fused trace leading up to the power supply FET drain. Fun times. Unintentional safety method. Yeah, literally every single one of them over this side is fused open. Boom, boom, boom. Funny times. Alright. I guess we're cutting all the power supply FETs out as well then. Full rebuild. Babies, I have a Saab with no accessories trigger anywhere. The only trigger I find is an antenna trigger for the red wire. I was afraid of pulling power through this trigger. No, you're fine. You can literally connect the red wire to any switch live, whether it is a logic level switch live or like it actually has current behind it. You just need to find something in the car that has 0 volts on it when the ignition's off, and that then has 12 volts on it when the ignition's on. It's just a logic level signal. It doesn't matter about how much current it's got behind it or anything like that. You're cool. Remember not to cut the rectifiers out, guys. I see so many people new to amplifier repair cutting the rectifiers out, because when you test with a multimeter, you're very used to seeing me and other people on YouTube testing for dead FETs like this and getting continuity between legs 1 and 3 and being like, oh yeah, that's dead. Well, the thing is, guys, you do that on the rectifier and it looks like it's a dead FET, but actually it's not. That's just you reading the DC resistance of the secondary wind of the transformer. If you want to check whether a rectifier is dead, you need to go between legs 1 and 2, like that, and 2 and 3. And you shouldn't have a continuous low resistance. If you do, then the rectifier is dead. But you generally always get a short between 1 and 3. That's just how rectifiers work. But I see so many times new people will cut these out thinking they're dead because they have a short on them. And that's kind of bad news, because they're not the easiest parts to come by. Yeah, they're not always available, especially common anode rectifiers. You can't always buy those. What's up, quad feed? My man's just joined, just rolled in. What's up, my friend? Have you noticed the massive gaping hole in the board yet? Woo! This is the loudest.com TL1021. Piece of crap. Did you shoot it? I mean, not yet. Shooting it would probably be a better use of this thing. Are the fuses really designed in that way, says Frank? No, not at all. It's just an accidental byproduct of the thin traces that this amplifier uses. Just a complete accident that happened. I was 99% sure of that, just not used in modern cars. Yeah, no worries, man. It's always better to ask, isn't it? Just get a second opinion. Okay, let's get all these legs out. Now, because the power... Now, this is going to be an interesting one. I wonder whether the power supply drive circuit survived, because in this failure, because the traces on the back of the board fused open what looks like so quickly, like they seem to have fused open pretty much as soon as the FETs shorted. They went boom, and then the traces opened up. I imagine the drive circuit probably survived because it won't have been getting current for long enough through the gate resistor to really cause any damage to the PNP driver, and the gate resistors looked visibly okay from what I quickly glanced at. So I think power supply drive circuit might actually be fine, just due to the way that the traces opened up on the back here. Hey guys, do you want to know one shortcut actually that we could do? So basically, this amplifier is very old. This amplifier was made in like the early 2000s, okay? We're now 20 years later. Semiconductor technology has come a long way in 20 years. So this amplifier uses, what is it, how many power supply FETs? 1, 2, 3, 4, 5, 6. It uses 6 power supply FETs per transformer, okay? And each one of these boards is barely doing 1300 watts. We have modern power supply MOSFETs that are like 10 times as powerful as the FETs that were used in this amplifier at the time. So technically, I could, instead of fitting like 3 FETs per bank of the power supply transformer, I could just fit 1 MOSFET per bank, 1 high power MOSFET, like, I don't know, a IRFB 3077 or something like that. And that would actually be more than adequate to drive 1300 watts, and that would be much quicker. But problem is, it would look wrong. Like if anyone opened the amplifier up and they saw, like, you know, 2/3 of the MOSFETs missing on one part of the board, they'd be like, huh? Who's repaired this? Oh, what? There's just like skimped out, cheap job. They haven't put all the FETs in. Blah, blah, blah. Without actually understanding why or what they are or anything like that. So I think just to keep everyone happy, we're going to use some lower powered MOSFETs in parallel like they originally did from factory, just so that it looks the same. You know what actually is 6? I think this solder socket is a bit too powerful now. It's actually throwing the end off. That does feel a bit more powerful, not gonna lie. It does feel a bit better. Jamie, how's it going, buddy? Good to see you in the chat. Quadfeed, this reminds me, I have a dead Soundstream amp somewhere. What model is it, buddy? And 2 Sundown amps. Oh dear, what models? Not the Salt series by any chance? Yalon, how's it going, buddy? Evening, good to see you here as always. Sundown, Saz 4500 and a Sax 200.4. Oh, what kind of circuit is the 200.4 using? I don't think I might have worked on one of those, but I can't recall it. If it's one of the newer kind of Class D4 channels, it's probably using the RS 209.3, which they have a common problem with heat and cool cycles. They just need a reflow if you don't read any dead output FETs. Ba -ba 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 -ba. Where's my hammer? Alright, so I think we're good now on the power supply FET pads. Like I said earlier, I've got a funky feeling that I think the drive circuit's probably alright in this case. Let's just have a quick little zoom in peek at the gate resistance. We've got 47 ohm gates on the power supply FETs in this thing, which is nice and high, so really there's not going to be a great deal of current passing through there in a short amount of time. You know, if the things fused open as quickly as they did. So let's just have a little peek at these. Visibly, they look at there is one over here that's toast. There is one over here that's kind of toasted. But did that send enough current down the gate path to the drivers? Uh-oh. Yep, it did. Okay, let's have a little zoom in on the drive circuit for you guys. This is like one of the most difficult amps to like work on for the camera because it's so long. There you go, see that drive transistor? It's got a big old lump on it. So yeah, the drive circuit did get toasted. No worries, let's replace all the drive transistors to be on the safe side. I'm trying to angle my camera over that way. It's so annoying working on these big boards, like I freaking keep changing the camera angle around and around. Alright, there we go. So we're going to have, we've got two transformers, so we're probably going to have 4 drivers per side. Let's just check this. So where's one of the drivers for this bank? There we go, there's one. And there's 2. Okay, so we've got 2 drivers here, you can't really see because of these. So these 2 drivers for this bank. And then, what about this bank? Here we go, these 2 drivers for this bank. And then this is the one that's got a bit of a hole in it. So is that one going to be the drivers for this side? I would have thought they were down here at the bottom. Yeah, they are. So, okay, what is this transistor that's got a massive bloody lump in it then? Because that's not a driver directly for the power supply FETs. That's really strange. Usually they don't fail if Usually it's just the drivers that fail. Alright, well we'll have to replace that anyway. That is labelled up as an M6. What is that doing? Is that supplying, that could be supplying the NPNs with their 12 volts maybe? I'm not sure. Not sure, but let's replace it. Let's get some hot air gun turned on. Your SPM with the solder sucker is quite impressive. What does SPM stand for? Let's have a look at some of this. Is this using 640s in the output? Mr. Francis? Yes it is, sir. The old classic Type 4. Oh, it depends on the length of the message. Says is 6. Ah, interesting. Okay. I guess if you're sending a long message, it costs more money. DJ Bell, what's up, buddy? Most powerful MOSFET. Like, there's no one answer to that really. Depends on the voltage that you need. Once you start getting into really high currents, you start wanting an IGBT anyway. Like, you think about the kind of silicon that drives, I don't know, like high-speed train motors, like the inverters in high-speed trains and stuff. You're talking like thousands of amps for each IGBT. They're like massive things with like many bolts that like clamped to a massive heatsink. One of them has a small transistor supply, 12 volts to the 494. Yeah, let's see if that one that's burned out is supplying the 494. I can't see why that would be though, but 494 supply is on pin 12. So that's going to be 9, 10, 11, 12. Yeah, it does have continuity to that burned transistor there. But then again, it also has continuity to the NPN drive transistor. Because, well, it's all the same. It's all the same supply chain. It's all the same supply rail. But yeah, maybe that is the one that's generating. Well, it could also be this one. We've got an M6 up here. But yeah, maybe it got killed from either one of the NPN. It definitely didn't get killed from the 494. The 494 won't have drawn current through that. Almost guarantee that. See you later. I'm going to leave the drive transistors themselves in just for a sec because, like I say, I've got a feeling they might be alright. Let's just give them a quick multimeter check. So we've got no shorts on them. Usually it's the PNPs that get hit really bad. But because of the way that the trace is fused open, I don't think they would have got hit that bad at all. So let's replace that. It was an M6 there originally, but I think we'll get away with a... Is M the NPN or the PNP one? I think it's probably, if we got the M's connected to ground. Okay, yeah, the M is a PNP, so we need a PNP in there. So I'm going to drop a 2T in there, just because they're pretty good parts, and I've got loads of them on hand. In you go. A little bit of flux on there, and that'll be in. What's up, Henrik? Yo, yo, yo! Oh, sucks per minute. Yeah, I've got them pretty handy with it over the years. Okay, so that's that back in place. Nice 2T in there. So yeah, let's just whack some power into it and see whether we're getting pulses come through the drivers. I don't know if we will, but let's just check anyways. New hot air gun, who this? Oh yeah, it's just an extra tip. My tip broke off of the original one, and I saw some angled tips on eBay, and I was like, yo, I could do with that in my life. So I bought them up, and honestly, it's been a lifesaver. Guys, if any of you have like a hot air gun kind of soldering thing like this, long nozzle with a bent tip, absolute game changer. Honestly, it's been amazingly useful. Okay, so we are looking for 25 kilohertz, there or thereabouts, PWM on the MOSFET gate pad, please. Yes. Stick our probe in the gate pad and set our oscilloscope to about 10 microseconds divide, I think that is. US nanoseconds, I don't know. 10 US on the old Scoper Ruby. Let's hit the power supply and see what she says. Oh yes, we had a little something there for a minute. Okay, let's reject high frequency. So we got 27.5 kilohertz. It looks a bit noisy, but that's just due to my scope grounding. It's a bit janky just because I don't like having the wire. So all that noise, ignore that. That's not really there on the circuit. You notice if I probe the ground, it's also there on the ground. So it's not actually there. It's just noise on the scope due to how I've got this connected. However, the problem, actually, I've just noticed a bit of an issue with this. That waveform is not really high enough. What have we got? We're going up to 4. We've got about 4 volts peak to peak there. I don't think that's really high enough. Let's check some other banks. We should have it going up to 12 volts. Ooh, that's not what we want to see. So yeah, that's not very nice. We've got some PWM riding on some DC there on that bank. Let's flip over to another bank over this side. Again, 1.3 volts, that's even smaller. And then over this one, that's another. So yeah, basically the drivers are all toast. Okay, new drivers. Why don't you get an electric sucker? I had an electric sucker. I found it took longer to use than the manual one. It was quicker initially, but then they will always get clogged up, and you have to empty the little canister thing, and you have to wait for it to heat up. And I found it just taking longer in general than just using a manual one. And also, the decent one that I'd want is like £400. And do you know how many of these I could buy for £400? Lifetime supply. And it's just something else to have plugged in with another wire. Do you know what I mean? Like, honestly, I find this like nothing. I have never been what's the word? I've never not been able to progress in a repair from using this. And I'm very fast with it and very efficient with it, and it doesn't annoy me. So I guess I'll stick with it for now. But I did have one, and it just kind of drove me nuts, to be honest. So yeah, guys, say bye-bye to the drivers. Bye-bye, drivers. See you later. I've got some IXFK 520N075. What's that? 520 amps, 75 volts? What package are they? have a Hakko solder sucker. I'm addicted to it. Well, maybe I need to try a Hakko. I haven't tried a Hakko yet, so because they're very expensive in the UK. The US version is very affordable, but it doesn't work in the UK with the voltages. So 1, 2, and then should have, was it 3, 4 up here? 3, 4. Yeah, there we go. So an M and an M. So let's replace the PNPs first. A little bit of flux on the board. And let's get my drawer of 2Ts out. I'm running a bit low on these actually by the looks of it, hey? There we go, there's my 2Ts. So let's go 1, 2, 3, 4. I'll get my 2Xs out ready as well, shall I? Here's my 2Xs. Let's drop those on the other side of the board out of the way. Let's drop those over here on the heat sink, I think. One, 2, 3, 4. Lovely jubbly. Mr. Carlson has a Hakko that he's hot rodded with a more powerful pump motor, worth a watch even just for entertainment value. Now that sounds like something that I would be interested in, because the more powerful pump motor would prevent it from getting clogged up as easily. Yeah, the one that I had was just pain in ass to use. Pain in my asshole. Okay, there's 4 new PNPs. Now let's quickly do the NPNs. There's 1 removed, 2 removed, 3 removed, 3rd removed, and 4th removed. 4th removed, that's like in the country where they're like, how many cousins removed until it's acceptable? Bit of flux. And drop our NPNs in. Alright. Oh no! I've lost my transistor under the bloody power terminal. It's just like slid under. Alright, let's get that out. Come on, fucking. Come on, get out of there. Alright, there's that one. Oh, I think it came out, just not sure where. Guess we'll just have to get another one out then. I'm sure I heard it fall on the heatsink somewhere. There's one. There's the one that I lost under the transformer. So where's the one that fell under the terminal? Gone. Gone forever, it would appear. No problem, we'll get another one out. Hi Dominic, how's it going? Yeah, hot air station, only really worth it if you're always going to be using it. You can actually do pretty much most hot air station rework kind of soldering stuff with a with an iron and a bit of skill. You don't actually need always a hot air station. If you're really skilled with an iron, you can do most of the stuff just with a regular iron. Sometimes it's actually preferable to use a regular iron, especially for parts that are very sensitive to high temperatures for long durations. Op amps seem to be really sensitive to that, like TL072. If you're replacing 072s, I always nowadays just solder them on leg at a time with the iron, just because I've had bad experiences with soldering them on with a heat gun and then just having issues with that circuit that I'm looking for, and it turns out to be the new 072 that I fitted that's kind of bad now, and then soldering them leg by leg, then it just works, and I'm like, oh, it was that all along. Adrian, I learned so much from your vids. Awesome, that's the plan, buddy. I'm glad to hear it. That's why we do this. Unclogging is not part of the fun. How hard is it to boil the silicon in the driver's FET? I have no idea. I don't wonder what the boiling temperature is. Nine Nails, just popping in on my lunch break. Hope you enjoy your lunch, buddy. What are you having for lunch? I've only got one glass of Ribena left in the bottles since 30 minutes into the stream. Bloody hell. Like a fish. Drinking like a fish. Greetings from Germany. Do you have a Vibe M21K? What do you think about those amps? I actually did a whole video going over what I think about those amps. If you want to search on YouTube, the video is called New Full Bridge from Korea or something like that. Bearvids. Just search that and you'll see I go through the entire circuit. This was like 5 years ago now. I have more thoughts on them now since that video, but it's still a good watch. Alright, so after fitting the new drivers, let's double check, see what our drive is saying now then, shall we? So we're looking for, oh, that's better. See, that's what I was looking for. Up to 12 volts, 5, 10, 11, 12. There we go, that's what we need. 12 volts peak to peak, 7 volts RMS. That's what we were looking for. No DC offset on any of these either, which is good, so the drivers were just completely buggered. Yep, looks perfect. Love to see it. Somebody's bellem my telephone. What are we saying? Okay, my guy is sending me a in phase 7000D. Sonna says, oh man, I apologise, I can't read whatever language you typed in. Something about TIP 35C 36. Maybe that says like what replacements can you use? I don't know. But you can still buy TIP 35, 36, so go for the original part if you can. Otherwise, check to see what other parts are in stock and available and compare the data sheets to the original data sheets. Cool, so now we have confirmed that the drivers are okay on this. We can fit some new power supply FETs. Oh yes. Power supply FETs we're going to be fitting are these, which are something you probably haven't seen from me before. IRF 1010EZ. And I'm fitting these. Because they're nice and easy. That's why I'm easy. I'm easy like Sunday morning. Yeah. Now these were just some nice cheap, these were actually some of the cheapest MOSFETs that were from my supplier that pretty much have identical performance to the 3205. It doesn't look like it at first glance if you just look at the current rating, but if you look at the good old safe operational area graph, which is the most important one, they're actually very similar in performance to 3205s, but they were like a fraction of the price, and they have pretty good power dissipation. Other specs were fine, so I use these in these kind of amplifiers that we're using, the 50NF06 or whatever, because they're better than those parts anyway. So yeah, karaoke night in the workshop. What are we saying, guys? Been a late night workshop karaoke. Love to see it. That hole needs sucking a little bit more. I'm going to turn the hot air gun off for now. Going by that, actually, I wonder whether the output drivers probably are toast anyway. That hole needs sucking a bit more. It certainly does. It certainly does. Oh, could you give those caps a wiggle for quad? Yo, quad, check this out. Why do so many expensive subwoofers and speakers use CCA voice coils, not 100% copper? To be honest, I'm not like a subwoofer designer, so I don't know for sure, but aluminium is lighter than copper. That might have something to do with it. Having a lighter moving mass is beneficial in some applications, so it could be to do with having a nice light moving mass, keeping the MMS down. Might also have something to do with aluminium having a lower thermal mass, maybe, so that it cools better. Heat dissipation. Heat dissipation. Yeah, that could be something to do with it as well. But yeah, guess you could ask Mr. Sundown, because he actually does he actually does really good R&D in his woofers. Mr. Sundown actually thinks about a lot of the stuff with the subwoofer design. Where's my solder gone? Here it is. Doesn't aluminium have a slightly higher resistance but a lower thermal mass? Yeah, it definitely has a higher resistance. Not sure about the thermal mass, but probably has a lower thermal mass. Just because it's like less heavy, it's less dense, so it's got less like material to hold on to the heat. So but to be honest, you don't always want like super lightweight moving mass in a subwoofer, you know, driver. Having a bit of weight to the moving mass actually, you know, improves the woofer's ability to play lows with ease. If you've got a really light moving mass, then it doesn't sort of, how to explain this, it doesn't really keep going, it doesn't want to keep oscillating at those lower frequencies as much as a heavier cone will. Better for you know, better for SQ, better for your punchy stuff, but just for slamming them lows, doesn't really matter. Glue shit to the cone, yeah, man. I have seen that done. Anyone who's an OG subscriber of mine may remember the JVC subwoofer and the Sony 8-inch subwoofer. So the JVC 6-inch and the Sony 8-inch. And those drivers actually had a purposefully heavy dust cap. They were like a thick cardboard massy dust cap in order to lower the FS of the driver. And so yeah, that's definitely a thing. Will you be bringing back Boom or Bust? Yep, yeah boy. I am brainstorming a season 2 and what changes I'm going to make. I do need to apologise actually to one guy. I made a comment on Parker the Basshead's video on his Big Boss 8 review, and just someone replied to my comment, nothing to do with what I said, they were just curious about Boom or Bust. And the guy asked me something about, could I do Boom or Bust season 2 with, he said it'd be better if you use like something like an 8-inch driver, you know, with like a wooden box and a bigger test cabin, and people would be able to relate to that more, and etc. His comment was super nice, by the way. Like he was really positive and really like, he was saying he really enjoyed the series and stuff. And I think I was just having a bit of an off day. Sometimes happens, and I looked past all of his like nice comments and stuff, and I just kind of read like, can you do Boom or Bust with like larger drivers, realistic drivers, etc. And so I just kind of said like, dude, like how am I going to make all these test boxes for like an 8-inch driver? How am I going to make a test cabin for an 8-inch driver like in my place? You know, I'm gonna like, for example, the boxes like the Fibonacci 4th, I'd have to build that out of wood. It's going to take me weeks per box, and it's going to take my time. Whereas 3D printing them, that can just be going on while I'm repairing and stuff. I just kind of said like, nah, man, what the hell? Why would I do that kind of thing? And I apologise because my comment probably came across a little bit like rude or a little bit like unsympathetic to his suggestions. But now at the end of the day, Boom or Bust it's got to stay It's got to stay in the scaled form factor. It's got to stay 3D printable. That was the whole point of it, was for people to be able to run wild with their designs and create something that would be very difficult to make out of wood, just to see how their crazy, wacky ideas would perform. Because 3D print, you can 3D print anything, you can 3D print any shape, no problem. And with it being scaled that small, obviously you can 3D print it, and it's very manageable for me. I don't have to make every enclosure that people design out of wood. And also there aren't many 8-inch drivers that would scale up to a 12-inch sub, because most 8-inch subwoofers are designed to play the same frequencies as a 12-inch. So yeah, just the whole kind of thing of it wouldn't really work. But no, I am brainstorming ideas for season 2. And some changes we're going to make. I was kind of toying with the idea, like I don't really want to do this, but the reason that I didn't really continue with season 1 was just because it was costing me a whole bunch of money to make every episode. Like, you know, the videos weren't getting enough views and stuff, so it was just costing me money. And I was really busy at the time as well with repairs. I was like, I can't keep this up. Like, every episode is costing me money. It's not getting the kind of views and the kind of responses that I was hoping for. So I was thinking, if I was going to continue Boom or Bust, it might have to be a YouTube membership series. But I don't really want to paywall it, because I feel like the information in there is really good, and I want it to be open to everyone to be able to learn and understand from. So I wanted the Boom or Bust videos to kind of pay for themselves just with the views and the ad revenue from the videos, but that wasn't really happening. So I kind of need to work out a kind of middle ground, some way that I can still make them, have them at least break even, so they're not costing me money to make, but so that they're still kind of available to everyone. But yeah, I'll figure something out, because I really enjoyed making those videos. Like, they've got to be the most enjoyable content that I've ever made on the channel. So I do want to continue it. I just got to try and figure out a more sustainable way for me to do so. Right, I'm just going to quickly get to the end of soldering these in, then I'll read all your live chats, read all your suggestions and tips and stuff. I'd like to try and get to the end of this amplifier on stream. Whenever I stream an amplifier, it always takes me like 4 times as long to get the repair done, because I'm chatting and explaining, showing things on camera. Trying to make sure that I solder over all of these broken traces. Unfortunately, the brakes are thin enough that a solder jump over them is adequate. Yep, there we go, all sorted on those. Let's just cut the legs off of those so they don't foul against the heatsink. And then we're going to power it up, and that's going to generate some rail voltage, and that's going to be fun, because we're going to see whether there's any short circuits in the PCB on the high voltage rails, and if there is, it's going to make some nice fireworks. So stick around for that. Delta says, oh, I didn't know there was a hole in the board. Oh yes, this one failed quite badly, eh? Okay. Alright, so we need at least one more gate resistor. I don't think the gate resistors mostly... Oh, sheesh, just knocked that bloody lamp down. I think the gate resistors seemed mostly okay. But we do need to check, because there was definitely one that was open over here, over this side. don't know if you can even really see this because this camera isn't very zoomed in, but it's fine. Let's get that over there. So there's a missing gate resistor over here that I'm just going to quickly refresh the pads on that, see if I can scratch away at some of the trace there so I can fit a surface mount resistor in place rather than bodging in a through hole. See, it's this one right here. Now where's the trace that leads there? So that's the gate. That's there. Okay. Yeah, I can definitely squeeze a surface mount in there. Yeah, that's fine. I need a 47 ohm gates. Classic. The classic gate resistor. 56, 68, 10, 47. There we go. I managed to buy my last batch of 47 ohm resistors that I bought, surface mount ones. I managed to buy them and they're not actually marked on the resistor. So you probably can't see, but they're just like black. They don't have the 47 written on them. So it was kind of hard to see what they were until I wrote it on the back here. I had to write 47 on the back so I could remember what these ones were. Now, I would normally hot air this, but I just turned my hot air gun off, so I'm just going to do it with the iron. There we go. Lovely stuff. Bit of isopropyl, clean up the flux. Just double check that. Yeah, it looks good, and we should have double gate resistor value on the multimeter. Man, the multimeter camera is like proper not happy these days. I need to get a new camera for the multimeter. So on the multimeter in diode mode we read 72 on one gate resistor, just because that's how diode mode works on resistances. So we should see double that on two that are paralleled together. 75. So, oh, actually these are looking a little bit out of tolerance. Do I need new gates all round? Maybe. Oh yeah, that one's reading 50. That one's reading 49. This one's reading 47 because I just bloody replaced it. That one's 47. Okay, so we've got two here that are out of tolerance. Oh, bloody hell. I was hoping we'd get away with all of these surviving. That one's 47. Okay, so there's only a couple there that are out of tolerance. Just these end two, these are out of tolerance. Let's have a look on the other side of the board. We've got a 47, that's fine. 46, that's fine. 47. The tolerances are quite high on these, so we can have 46 and 47 point something, but 50's a bit far out. 47.4, 47.3. okay, they're all fine. I'm actually missing a capacitor here in the middle of the board. I don't know what that is, what value that is. Little surface mount cap. It's probably not critical. I don't know if you can see that. There's a little surface mount cap here missing. Probably not critical, but I'm going to just reflow the pads there, drop something in place. It's probably an output side to main side ground cap. Just going to reflow those pads. Probably drop a film cap in there. Okay, so yes, we need a couple new gate resistors over this side, don't we? A couple of them that were out of tolerance. This one on the end here, and this one. One, two. Okay, there we go. There's some surface mount resistors with the main iron for you. Sam, do you still listen to any submissions from? Do you still listen to any of the submissions from Boom or Bust? Like listen to the enclosures? You mean? No, not at all. They all sounded horrible because they were like, you know, what was it, 150 to 300 hertz? So no. Oh, do you mean like listen to any submissions, like as in like receive submissions in the emails? Well, no one's submitted obviously for a long time because I haven't been doing the videos. Organised part spins like winning lottery numbers, yep. Adam says, one I'm working on this weekend stays on with a slow turn on but draws a bunch of current to turn on when over 9 volts. Stays on with a slow turn on but draws a bunch of current on turn on when over 9 volts. Once on it draws 0.47. That's a very low current draw. 0.47? What amp is that? Does it work once it stays on? I've actually worked on some really old Class D circuits that if you limit the current while turning them on, the Class D kind of like gets itself into a bit of a muddle and it builds this kind of really glitched oscillation, and in order for the amp to come on and not do that, you need to like massively crank up the current going into the amplifier so that it like starts instantly rather than like getting into this weird kind of muddled oscillation. An old Sundown, a couple of old Sundowns I've done have had that issue. Right, guys, we're ready. We're ready for high voltage rails, I do believe, on this bad boy. Let's just double check for solder bridges and all that jazz. Just do the old scrape with the thing here. Okay, lovely jubbly. Let's go back down. So we're looking for positive and negative rail voltages, and we're looking for PWM. Now, one of the reasons why I say these amps are nice to learn to repair on, because these amplifiers actually give you pulses on the gate pads with no MOSFETs fitted for both high side and low side. So you can kind of really see whether both sides of the amplifier are okay or not, without relying on the bootstrap to give you that. So let's turn on the supply. Right, 9.8 volts going in. Now these amplifiers, they want to build the rail voltage instantly. There's no soft start. So we're just going to whack our oscilloscope probe in here. I'm just going to touch the remote and you'll probably see that instantly jump down there. What's going on? Oh, it would actually help. It would help if I connected some bloody power to the board, wouldn't it? What's going on tonight, guys? What is going on? I'll tell you what, it's a bit warm in here. I'll blame it on that. It's a bit warm in here. Today was probably the mildest day of the year so far we've had. And I'm still in winter mode, so I was kind of getting my massive coat on and I was like, dude, wow, it's roasting. Okay, that's better. Right, power. There we go. 12 volts at the power supply MOSFET. Drain, you love to see it. Okay. Now we should build, there we go, instantaneous bit of rail voltage. As soon as we touch the remote, look, boom, boom, it's right there. No soft start at all in these. So yes, this is the low side over this half of the board, and this one with the fire, again, is the high side. Now interestingly, I don't actually have positive rail getting built over here. So as you can see, we've got negative rail there getting built. However, there's no positive rail. Okay, that's not good. Where's my positive rail? Maybe it is getting built, it's just not at the MOSFET gates. Oh yeah, obviously, because it's this broken trace, isn't it? Yeah, so this whole trace, that's the positive rail. So I just need to scratch away a little bit here. There we go, there's our posi rail. So 48 volts positive rail and 49, 50 volts negative rail. Yeah, that's about right. Yeah, a little bit of a difference between the two, but that's fine. Okay, so do we have oscillation? Okay, so we've got no low side drive at all, although maybe this is one of the boards that doesn't give you drive. In high side, you've got nothing on there either. Let me probe what is coming into the drive circuit. So like I say, usually with these, although the reason we might not get any oscillation, I've just had a bit of a realization. I think that part of this step down circuit uses the positive rail to build some of the supply voltages for the drive circuit perhaps. So that might be why we're not getting any drive yet, because I might just need to bridge over this broken trace. Let's just have a little peek and see if we've got anything going into the optocoupler. No, nothing on that side. There's actually I've got no VCC going into the optocoupler. We've also got no VCC on this. This is a 7805, so there's nothing on this 7805 voltage regulator. Negative 53. Yeah, this 5 volt reg's working. 9 volts. This 5 volt reg's working, but this one's not working. But I would have thought I'd still see low side drive, but I guess maybe not. 53, 48, 48. So we've got 5 volts into this optocoupler, but we don't have low side drive. Okay. Well, let's bridge over this positive rail to here. Now, I could do a electro boom, and I could touch my soldering iron onto here to try and solder it over, and it would bang, because these rail caps are still full of voltage because there's no pull down resistors. So if I was electro boom, that's what I'd do. I'd be like, oh yeah, let's just solder a bridge over here. Fuck. But we're not going to do that because we're not electro boom. We are going to discharge the rails first. So we've got negative rail over here on this rectifier, negative rail and positive rail is over there on that leg. So let's just jump that over. There we go, that should have discharged. I didn't hear any spark. No, why is it not discharging? Do I have a break in my... No. Okay, is that discharged now? No? What's going on? Oh, that's because I'm shorting high to high. Duh. Okay, where's another point for negative? Nope. I'll just have to go on the rectifier leg then. There we go. There's the spark that I wanted. There's the spark that I wanted. Okay, we're down at 0. Excellent. So let's scrape off a little bit of this burnt PCB here. To expose the copper trace. You've been exposed, sir. This copper has been exposed.
Oh no.
And this side as well. Go. Now we just need to run a bridge from one side to the other. Yes, please. This is absolutely overkill. It does not need to be that thick in the slightest. Do I have something a little thinner and easier to work with? I don't know if I do. Okay, I guess we'll go with the thick stuff. Another board with a hole. I know, right? What's going on? What is going on with these boards with holes recently, hey? The QC pass ticket is ironic. I know, it's hilarious, isn't it? It's perfect location for it. Dude, this is ghetto, man. This is ghetto. What even is this? Look, man's got a fusion here or something. I don't know. This is jank. Yeah, I'm going to drop a bit of flux on there. I think that will help out a lot. Bit of flux on these board pads here. See what we're saying. Oh, the plastic's melted. The plastic coating on the wire is melting, obviously, because we're soldering it like crazy, but it's fine, it's fine. It's all fine, guys. Don't you worry about that. Shah says, when I see you live, it's a blessing. Oh man, thank you very much. That's very kind of you to say. Appreciate that. I don't know about a blessing. Whew. Man's getting cancer from these fumes for your guys' entertainment. I'm going to crack a window actually. These fumes are like popping off in here. Do you have a fume extractor? Nope. I do not. I do not, unfortunately. Okay, so now that positive rail is working its way over to the output section, I guess we could see now if we got our drive PWM or not. So we should be getting positive rail over to this side now. There we go. Oh, something sounds like bad. Something sounded kind of bad over there, not gonna lie. There were some sounds on the board. I'm gonna put these on. Alright, what are we saying? Okay, let's see whether we get PWM. Okay, there's no PWM. I don't know whether these circuits just need the FETs fitted, actually, they might. It's slightly different to the base phase versions. Do we need the FETs fitted? I don't know. Boop. Ah, here we go. This 5-volt reg still isn't doing anything. Okay. Okay, so there's something up with whatever circuit this 5-volt reg is running with. Although it does that bootstrap. No, actually, you know what? That might actually be nothing. Because I think this 5-volt reg creates 5 volts reference to the low side switching, maybe? So I don't think that would have 5 volts on it anyway, without the low side oscillating. Okay. Okay. Let's probe the drive card. Let's see what we got on the drive card. Haven't really done too much work on these amps as far as drive circuit goes, because usually the drive circuit's just like absolutely fine. Nothing on there, so we've got nothing on there. So we've got 5 volts going in. Okay, so we've got 5 volts going in there, pin 3. Nothing, nothing, nothing. 9.2 volts, that's from the supply, it's fine. Negative 9.2, okay. Another 9.2 there. Nothing and nothing. So there's no pulses coming out of that. Now I had a feeling that you should always get PWM coming out of that. So that's interesting, but I do have a vague memory that these ones are a bit funky. These amps are a bit funky, and you kind of need everything together and you know, connected and FETs in. They're different to the base phase versions and the other cheap China versions. So I am going to, I think I'm going to just get rid of the rail voltage, dump that to ground, check a few semiconductor parts on the output section, and then I think I'm going to fit some FETs and just see what it does with the other board running as well. So let's just check a few of these diodes and whatnot on the board over here. Now we checked these drive transistors and these all read okay. The optocouplers, they'll be fine, they never die. Because yeah, there's this jumper wire that goes over to the other PCB, so I've got a feeling that both of these kind of need to have their supply voltages and stuff all kind of up and running and active in order to get PWM on both sides. So what I am going to do is drop some FETs into this side. Just one per bank for now, I think, just some sacrificial 640s. And I'm just going to get rid of the carbonized PCB from those power supply FETs there. Okay. Now, even though this board has like one dodgy random fitted power supply FET, this side of the board does work apparently, so yeah, so this side should oscillate and everything. So I'm going to just drop a couple of FETs, one per bank, into this side. I'm going to use some sacrificial 640s that are used and I don't care about, provided I can find some. Here we go, old 640, and here we go. Let's just drop a couple of random 640s in. Don't even have to be same batch really, although I'll use same batch, why not? And so if these explode, we don't really care because they're old and used anyway. Interesting actually. Hey, who spotted that? This Charlie, does that connector have a corroded pin? Yeah, actually, you know what? It does look a bit jank. They got some green marks. Looks like it could be a bit of moisture corrosion in there. Good catch on that. I'm just going to give that a quick clean out. I don't think it will be affecting its connection quality to the pin there, but yeah, that didn't look too great in there. Well spotted on that one. Just give that a quick in out. There we go. Just in case there was any. You know, it does feel kind of jank actually. Hey, you might have been onto something there. Just change everything, lol. So this won't have prevented the pulses just now because this is coming from the other PCB, but that might affect things going forward once we have everything connected. So yeah, it's a good catch. I'll keep an eye on that. So let's very quickly tack in these 640Ns. One per bank. just make sure the 47, no, I think it's a 10 ohm gate resistor. The 10 ohm gate resistor is intact on both of these ones that I fitted. Yep, it is indeed. Okay, fantastic. So now what we're going to do is reconnect this wire. So we've got this wire here that comes from the other board that leads to here, which is the remote wire for the other board. Okay, so we're going to power it up now and see what it does. The other board apparently should work. I've got these FETs off the heatsink because I'm curious to see whether this one's getting hot at idle. Just because it's the completely different FET to the rest of them. Someone's fitted that for some reason. Let's put our power wires back in. Connect up our remote terminal. There we go. Oh, okay, we've got a constant current draw. Something's not happy. You saw there, we had a constant current draw. So, does the other board actually, in fact, have a toasted power supply, or do we have a short somewhere else? So I am reading a dead short pretty much between... Well, that doesn't make any sense because we didn't have that a minute ago. Maybe there's a bit of solder or something that's dropped on the board somewhere? Ah, hang on. I think this little ground wire was literally just touching the drain of that FET. Get out of the way. Get out of the way. No, let's try that again. Okay, there. That's what it was. Just a tiny little ground wire was just touching the bloody drain of the FET. Right. So we build a little bit of rail. I want to see whether we have DC offset on this one, which we shouldn't. And this one should start oscillating straight away. Right, let's put our oscilloscope probe in there. And this could go bang, so watch out. I've got my safety glasses on. Hopefully this does not go bang, but it could, so let's see what it does. Oh, okay, well we have something on the oscilloscope there if you just saw, but it looked absolutely horrendous. So I'm going to go out on a whim and say that the drivers are bad on that side. Like, I don't want to do that again, just in case it causes further damage, but that looked pretty bad. That was not the kind of waveform that we are looking for. So we're going to change the drivers on the output side, and that should clear that up. So I'm just going to sync that rail voltage back down to ground. There we go. Bye bye rail. Now we're still going to have rail voltage on the other board over here, as you can see. I'm going to leave that there. I'm going to leave that active just because we're not touching that board. That's fine. Turn the hot air gun back on and let's start removing these drivers. So we've got a 2T and a couple of 2X's. Let's get these dropped out. Can you believe that this amplifier is only 3 kilowatts? 3000 watts from this huge thing. The Taramps HD 3K is like this big. You could fit, hang on, you could fit 1, 2, 3, you could fit 4 Taramps HD 3Ks for the size of this. 3.6, that's 12 kilowatts. This amplifier is actually longer and bigger than the Taramps bloody base 15K. Actually, it's almost as long. I wonder if it's as long as the Band of Viking 15K. I've actually got one of those behind me. We could compare. Comparetheamplifier.com. The fumes have gotten to you. Dude, no. I've always been like this. I've always been like this. 1, 2, 3, 4. I need to buy some more of these. Holy crap. These have lasted me like 6 years. 1, 2. There we go. There's all new drivers fitted. So just gonna let that cool down for a minute, and then hopefully we should have actually decent looking Class C switching on this low side drain. One more capacitor wiggle. Guys, you ready? Yeah, the band of Viking 15K is behind me, but it's got a bunch of stuff on top. Let's see if I can just knock that stuff off so we can get it in here. So here is the Van der Viking. Here's the Van der Viking 15K, and it's oh, you know, it's exactly the same size. What the heck? Exactly the same size. 15,000 watts, 3,000 watts, 15,000 watts, 3,000 watts. There you go. Is the capacitor even attached? Yeah, it actually is. That's not my work. The amplifier came in like that. I'm going to sort that out before it goes back to the customer. But yeah, it's just kind of chilling in there on some like long legs. I guess the previous guy, whoever worked on this, did a top board repair, so they soldered these in from the top of the board. So yeah. Canon camera works. Yes, it does. I just had to like take the battery out and put it back in, and it was fine. No, don't hot glue that. Never use hot glue in an amplifier. Sheesh. Alright, let's see then. Has the replacement drivers fixed our problem? Gonna power it up and see what it does. Oh, what the fuck? Well, nothing. We had a couple of little pulses before, didn't we? So why don't we have anything now? We had like janky looking pulses, whereas now there's nothing. Unless my probe just isn't. No, it's connected. What? Say what? Oh shit. Yeah, I got nothing. Before I changed the drivers, we at least had like... we had some switching, but it looked like a terrible shape. I wonder whether... oh, you know what it might... I'm sure that these amplifiers are fine with just 1 FET per bank. But maybe there's not enough like gate capacitance. Maybe I either need to fit all of the output FETs, or it needs a little bit of signal to kickstart it into oscillation, but I'm not used to seeing that with these. Usually it just works. This is the loudest.com TL1021. Let's go up to 12 volts real quick. 11. Let's go 11. Yeah, we've got nothing. The other side is definitely oscillating, because I can see it in the current draw. So if we go over to the other channel. There you go. That's what we should have. I think I'm just going to fit all new FETs just to see whether it's like not enough gate capacitance. Oh yeah, no, it tries. There's a little glitch. And then it tries. But why? And then we've got a little swing to negative to like down. That's so weird. All new drivers. Why would that not work? Unless it's like very, very fussy about the types of drivers. W2X. I fitted the same model of transistor, but maybe it's really fussy. I'm not used to seeing that with these Type 4s. Well, I guess the most sensible thing to try next would just be to fit all of them to see if it's a gate capacitance issue. If not, then as a proof of concept, we can try swapping the drivers from the good channel into this one, just as a proof of concept that it's not happy with these drive transistors. And the same model, 2x, 2t, 2x, 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 2t, 2t, 2x, 2x. Yep, exactly the same model of transistor fitted there in the drivers. We haven't knocked anything else off its pads. Everything is soldered correctly. So I guess next most sensible thing to try is just to see whether it requires more gate capacitance. So we're going to fit all of the FETs. Yeah, usually with these Type 4 amps you do get drive without the MOSFETs fitted. I agree with that. However, on these loudest.com models, for some reason, something's a bit different, because you don't actually always see gate drive without the FETs fitted. I've come across that before. Because just before we fitted these 1 FET per bank, we saw absolutely no drive at all. There was nothing. But then as soon as we fitted 1 FET per bank, we actually saw a little bit of drive. Granted, it was not the right shape and it looked disgusting, but we actually saw some drive there. So these are a bit different than your usual Type 4 for some reason. I don't really know what it is about them that's different, but something's different. I'm probably going to need to go from the underside of the board on these. That's fine. Okay, so let's load up some new 640Ns. Now, where are my 640Ns? I think, did I buy a whole bunch more recently, or did I not? Do you know what the funny thing is? I might not actually even have enough 640s because I think I ran out recently. I've got 4 in this drawer here, and these are not all the same batch. They're close enough. That one there. Right, these are all the same batch. That's 4 there. No, their power supply. Ah, there we go. There's the 640s. I thought I bought some new ones. I need to label my drawers, guys. So that's 4 in this side. Now we're going to have to get creative with the 4 on the other side, aren't we? We're going to have to get a bit creative with the ones over here where the hole's in the board. Okay, let's get that one in. There we go. Let's get that one in. There we go. Get that one in. There we go. I say in, it's not really in, is it? But it's fine. Let's get it, there's the one. Okay, well let's tack solder those in, and then we can fix the traces going to the other ones. Someone suggests a driver for boom or bust. I'll have to have a look at that in a bit. But the driver for boom or bust needs to be 2.5 inches for a 12 inch, or 3 inches for a 15. It needs to have an FS somewhere around the 200 hertz mark, and it needs to be able to accept around sort of 30 watts RMS would be cool, but 20 is fine. Gotta go eat. Enjoy your snack, my friend. Alcatraz, enjoy your snack. Thanks for sticking around. Catch you next time. Okay, so let's make a connection up to positive rail on these ones that are lacking it. We're also lacking, actually, there's a big trace here that's lacking. Let's have a look. What is that supposed to connect to? We've got that one there. Okay, low side. That's the low side drain on this side, which is supposed to connect over to the source. Okay, the source. This side. So yeah, we need a few jumpers over here. There to there as well. And positive. That one actually still is connected to positive rail, so we'll just do that there. Ooh. SSD. Gate, source. So we need something to jump over to positive rail on this pin. That can go there, that's good. Let's just bend that over. Let's give you this camera so you can see what I'm doing. Did you fix the 5 volt? Well, actually it turns out that 5 volt regulator actually works off the bootstrap supply that runs off of the low side drain, so that 5 volt isn't going to have anything on it until the low side starts oscillating. Nice. And then we also need a jumper over to the low side drain coming from the low side, which is the bootstrap ground supply basically, which is this trace right here, so that can go there. And then we also need one of those for this FET over here. So let's see. Maybe I can just go this trace. It's not there. It might be best just to kind of go across. No, that's because that's where the board's going to sit in the heat sink there. So I don't want that anywhere near that. So maybe I'll have to go around this way perhaps. It's a bit sketchy, but if I've got a long enough. Yeah, I can't go along the edge. So I think I'm just going to kind of have to go along this way. Connect up two of these together. Did you fix the 5 volt? As I said just a moment ago, that 5 volt regulator is using the low side switching for a bootstrap supply. So you're not going to get 5 volts on it until the low side starts oscillating. So the reason I didn't get 5 volts was obviously because we don't have any low side switching yet, because we didn't have any FETs fitted, etc. So we're only going to see 5 volts on that when the low side starts oscillating. And it's going to be referenced to the low side drain as its ground, so that's not going to give us 5 volts DC that we're going to be able to read on a scope or anything like that. That's going to give us 5 volts against the low side switching, because this has a bootstrapped high side. Oh dude, Doug man, thank you so much for the 10 buddy, care package. Absolute legend. I love to see it man, thank you very much buddy, appreciate that. Can't believe you're still here dude. What are you doing? What are you doing? But thank you very much for the 10, that's super appreciated buddy. So all we've got to do now that we've done that, everything is connected up. We've got positive rail on this one, all of these are connected. We've got low side drain connected to all of the sources of our high side. Now all we need is a couple gate resistors on these FETs that had them missing. So the ones that we've got gate resistors missing is this one has connectivity, as you can see. This one actually does have connectivity through some magical 10 ohm resistor right there on the board. So the only one that we need is this one right here. So we need a 10 ohm resistor on this one. Also one of these up here had an open 10 ohm, and that's this one right here. So let's turn the hot air gun on. Actually, I'm just, now you know what, I'm not going to bother hot air gunning it. I'm just going to use the regular iron because it's quicker. Let's get rid of that 10 ohm right there and drop a new one in its place. Guys, actually, you know what, this repair totally wasn't worth it for what I'm going to be able to charge the customer, but screw it. It's good fun, innit? It's good fun, innit? Well, I guess it's not really fun, but I can just pretend it's fun to make it seem like it's worthwhile. What are we doing? There you go, there's a new 10 on that gate. And last but not least, we need a through hole 10. Just going to get my through holes from here for that one that is missing. There we go, there's a through hole 10. Is that, yeah, brown, black, black. There we go, yeah, that's the through hole 10. And in order for that to work, we need to solder it to this leg right here, the gate. I'm actually going to cut it quite short because we want the resistor actually quite close to the MOSFET gate, otherwise we get a bit of ringing. So I'm going to cut the leg quite short by the gate, and then we're going to use the rest of the length of the resistor to bridge us over to where we need to go. There we go. Now that needs to work its way over to go over to this one. I think might be the most sensible. If we can reach, can it reach? Yeah, just about reach over there. I really hope that this sorts it, guys, because I don't know what else would be wrong with this, other than maybe that it just wasn't happy with the batch of drive transistors I fitted. It could be really fussy with the current gain of the drive transistors, perhaps. Right, there we go. So, just a sanity check. We come out of the gate driver 10, 10, 10, 10. No shorts across any of these. Nope, nope, and nope. Out of the driver 10, 10, 10, 10. No shorts, no shorts, no shorts, no shorts. Okay, no shorted diode, no shorted diode. Okay, so now we power it up and see what the bloody hell it does. Hopefully it gives us class D switching. If not, then it will be an issue. If it doesn't give us class D switching, then it will just be an issue with the current gain of the batch of drive transistors that we fitted, which is massively a shame. I've never seen that happen before. We're just going to have to kind of experiment with replacements until we find a batch that it's happy with. But yeah, hopefully it just bloody works. So we've still got rail voltage in the other side. This is the side that we're interested in here. So we're going to take our oscilloscope probe, chuck it in the low side drain, power supply on. And start off down at 9.8 volts to keep the rail voltage nice and low, just for safety. Keep your eyes on the scope and let's see what happens. Ah, fucking hell! No, still nothing. We've got like a little swing to negative. You know what I think I'm going to do, guys? I'm just going to replace the drivers again. Maybe I slightly overcooked. Maybe we got one dodgy T2 driver, or maybe we just accidentally overcooked one with the hot air gun. I've never done that before. But honestly, this is all of the signs of dodgy drivers. So I think maybe just replace all the drivers again. I'm going to start by replacing the T2s because I've got more of those in stock. And I'm just going to maybe give them a bit less heat this time, just in case they got a bit cooked. I've never seen that happen, but just a bit bamboozled because I've never seen that happen. These are usually like the easiest amps to fix. I just need to wait for this to heat up a bit now. Right, T2 away, 2T away. Okay, so let's just be real careful with these new ones. Nice bit of flux, and let's just be real gentle with the hot air gun, just in case that had anything to do with it. I've never killed a 2T with a hot air gun before, but first time for everything. Right, there we go. That's just enough heat on there to get that soldered in. And again on this one. Once again, just enough heat there, and we're soldered in. 2X's might be bad, but you know what, I don't actually think I've got enough. I haven't got 4 2X's left, I've only got 1 2X left, so I'm just going to let that cool down and just see whether it was the 2T's that were the ones that had got damaged. Man, I have no idea. This is definitely the one of the most challenging Type 4s that I've done for some reason. Partly to do with the hole in the board, but also this kind of output drive circuit seems to be a bit playing games. Okay, so that's a couple new 2Ts. Hopefully that's all it needed. Let's try that again. Oh wait, no, we got a bit of DC on the positive side. No, we shouldn't have that. Okay, maybe the 2X's are bad. Fuck. Wow, what have I got to replace those? Maybe I overcooked them. Right, what I'm going to have to do is one left in here. Let's have a quick look in this drawer. 2T, 2T, 2T. There's the 2X. I've literally just run out of these. I've probably got some on a donor board somewhere, but just not in the workshop with me right now, and it's getting a bit late, so I was hoping to just get this, done and dusted. Right, let's just check some multimeter readings between these. Let's see if we can find the one that's dodgy. Right, so 2X's we should have. Got 643, that one. Right, got a slightly different value there. Okay. 643, 582. 580, 547. Oh, okay. 6. Yeah, we've got different readings here. I want to know which one's the bad one. That's open. That's open. 627. 636, 578, 577. Right, so these are reading about the same. But this one here is reading a bit whack. 570, 602, 16, 16, 575, 577, 550. Yeah, okay, I'm going to remove... Oh, I just lost one of my new 2Ts because it got stuck to my hand and it fell off. So I'm down to one. I'm down to one 2X, guys, that's left. I'm going to have to be really tactical with this. I'm going to remove this one here. And I think what we're going to do is drop it in the transistor tester and see what it's reading as. Don't worry, that's not the problem. And that's not something that I fitted either, for those of you that recently joined. These caps came like that from whoever else has worked on this amp in the past. But they are actually connected, so we're leaving them like that for now, and we'll sort them out later. Okay, I'm just dropping this 2X into the tester. Okay, let that cool down. And I'm actually just going to drop this brand new one in over here anyway while we're here. Okay, so let's give this a quick cheeky test. Right, that is currently reading as an NPN transistor with a current gain of 437. Vale, vale, vale. Let's check this one over here. Alright, what's this one reading as? This one is reading as... Okay, well that's reading pretty much the same, 435. I guess we check the other two next to it now. I wonder if one of the opticouplers died. That would be quite rare. I have seen it before though. But I'd be quite surprised because we did kind of get pulses earlier. Okay, yep, that's reading correct as a transistor with the same current gain as the rest. So let's just go ahead and check this one last one. Yep, that's also reading beautifully as a transistor with the same current gain as the rest of them. So all of these are fine. So there should be no reason why this doesn't work other than perhaps a dead optocoupler. So I'm going to power it up again, and we're going to see if we've got pulses going into the optocouplers. I don't really like the idea of leaving it on too long though, because there could be some drive glitch and we could kill some output FETs we've just fitted. But you know what? It is what it is. So let's power up again, and let's just have a quick probe on. See, we're getting 8 volts on there. It shouldn't be there. We've got leakage. 48 and 47. Right, let's just leave it on and see if it oscillates. Fuck it. Okay. No oscillation. Let's have a look and see if we've got pulses going into the optocouplers, shall we? So, we'll go into this one. Nothing into there. Nothing, nothing, and nothing. Nothing into there, nothing into there, nothing into there, nothing into there. Let's check on the low side. Nothing, no. Oh, little attempts at pulses there. Nothing, nothing. Nothing. Nothing, nothing, and nothing. Okay, well, I guess the next thing really is to just change the optocouplers. If that doesn't work, then I'm a bit bamboozled with this Type 4. Probably have to just go with trying to... If that doesn't work, what I'm probably going to do is swap the drivers from this side that work into this side, just to see if it's like it needs a specific current gain of driver in this circuit for some fucking random whatever reason. So I'm going to change out the optocouplers, and we're going to do this with a hot air gun because it's quicker initially. We're going to just remove them with a hot air gun. It's so much faster. Especially with a low thermal mass PCB like this. That's one out. Two out. There's one trace here which is on ground that's got a bit of thermal mass to it. Might have to go in from the underside just to clean that up. Didn't really want to have to remove my power wires just because it's a pain in the arse, but whatever. Yep, that is a thick ass trace on the back there. Let's remove the power wires. Let's just just get rid of all these bits of solder, because I'm going to flip this board over now onto the good side, and the good side still has full rail voltage sitting in the caps, so I don't want to like spill any bits of solder or anything over there. There we go. That's all it needed. Okay. And I've got to find my optocouplers. I've got them in a special drawer somewhere. Is it in this drawer? Might be these. Is it these? LM6171. No, it's the optocouplers are 6N or something. So I don't think it's any of these. I do have a special drawer for them somewhere. Might have even written it down. Opto. Here we go. Optocouplers. Muy bien. There we go. Right. There's two here. Okay, let's get that soldered in. What's up, bro? Okay, new optocoupler is fitted. What you saying? What are you saying now, bro? If it's not the optocouplers, then what is it? Check all the resistors around here. Got a couple of 100 ohms. 77, 76. Yeah, that's all right. A couple of diodes. 3. What's up, Mario? Okay, so that's the optocouplers replaced. See if that makes any difference now, shall we? Right. Oscilloscope in the low side drain. Okay. I don't think this is going to work, guys. We've got DC offset there again. What the fuck? Why have we got like 6 volts there? Doesn't make any sense. Where's that coming from? Oh, I saw a tiny little bit of switching there. Did you see that? It must be the drive transistors it's not happy with or something. There's like a little attempt at Class D there, but then it just fucking goes away. What are you not happy about, bro? Are you not happy with your 5V reg, or are you not happy with your drive transistors, or what? Fucking something. There's like a bit of DC on there as well. That's like mega not supposed to be there. Now hang on a minute. I'm spying something over here. There is differences between these two boards around this sort of 5V rig. So we've got this diode D16. On this one we get 2 volts RMS wave. On this one, fucking would help if the amp did the same bloody turn on sequence every time. On this one we get nothing to start with. And that's because that doesn't start oscillating right away, whereas this one for some reason does. Okay, we've got differences in the power supply side by the looks of it. This board for some reason comes alive instantly, whereas the other board doesn't come alive until like something is happy. But that shouldn't affect the output section though, surely. There's something interesting going on with the high side bootstrap supply. I don't really know if I can explain this. So basically, on this board, which isn't working correctly, okay, on the scope screen here, if I probe the input to this diode D19 right by this 5-volt reg, okay, we get this little bit of drive. We get this little bit of AC, okay, riding along sort of negative voltage. You see that? Whereas on the good board, before Class D switching initializes, we actually get like a much bigger square wave. So there's something wrong with this circuit over here for the high side bootstrap 5-volt supply. That's what we just need to turn our attention to briefly. I'm only going to do this for a little bit longer because it is kind of late, but I think we might be honing in on the issue. So let's use our good board over here to compare. So I'm actually just going to go ahead and short out the rails on the good board as well. There we go, don't want that doing anything funky. So, on the good board obviously over here we're supposed to have D16 connected to the transformer over here. Now the other side of the transformer obviously has continuity, but I believe is supposed to connect to, let's see, any of these? The high side source over there, right, let's see. Aha! Well, there's your problem. There's your problem, guys. So see how this transformer, this side has continuity to basically low side drain, because that's the ground reference for the high side bootstrap. Whereas on this board, obviously the trace is missing through the hole in the board, so we don't actually have any continuity to there. So what we need to do is just ping a jumper wire from this trace here. We're going to get this working tonight, guys. So that comes through under there. Right, makes sense, yeah, there's a trace missing that I'd kind of not really noticed. There we go, there it is. On the underside of the board, there's the via. And that's supposed to connect through to here. Okay, fantastic. Just a tiny little jumper wire and we should be good to go. Bloody hell, right. So let's just put a little bit of solder on there. Let's try and squeeze this into the hole, into the via. In you go, lovely jubbly, look at that, straight in there like a champ. And then we just need to solder that onto there. Didn't need to replace those bloody opticouplers, but sometimes you got to just do the trial and error. Probably didn't even need to replace the drive transistors. They were probably fine, lads. Okay, so now the high side bootstrap has a ground reference that it's supposed to have. So, let's just check all of that continuity. High side over here. Yeah, that's now got continuity where it's supposed to. Okie dokie. So now we do a power up and see what happens. Guys, you're going to find out what happens next after the break. Don't go anywhere, guys. After the break, find out what happens next. Boom. And for those of you that are still here, congratulations, your ad blocker works, or your YouTube Premium works, or you just didn't get an ad. Okay, so let's connect up these power wires. So 12 volts from grounds. And remote. Okay, so guys, moment of truth then. Do we get Class D switching? Or does it explode? Who knows, it might still explode, you never know. You never know, it might still actually explode. Ready, here we go. Uh-oh. Oh, fucking hell. Why still no? We get an attempt, and then we just get a fucking swing to negative. What? What? Is there still a trace that's missing or something? Let's check this high side supply diode now again. Right, that is still wrong. That is still freaking wrong. That's correct. Right, that's there. That's there. Oh, it works. Wait, does it? Does it work? Oh no. Does it work? Yeah, it works. Woo! So why does it only work sometimes though? That's a bit concerning. I feel like maybe there's a dodgy solder connection or something somewhere, because I prodded around at the transformer over here and it started working. So I'm going to have a prod around. Let's just try it again. Right, there we go. Class D switching for your ass. Okay, fantastic. So I think I still need to have a little poke around, but we do now have, at long last, Class D switching on the faulty board. Amazing. Amazing, amazing. Guys, what a journey it's been this evening. It's quite late here in the UK now, much later than I was intending to stream to. But I hope you had fun. I hope you enjoyed the stream. Hope you learned something. I learned that there's a trace that goes under that bit of the board where there's a hole. So that's what I learned this evening. Fucking thing. Will it pound a sub? Yes, it will pound a sub, but that'll have to wait for tomorrow's live stream or something like that. Because I am tired. It is 11 PM here in the UK, so I'm going to go and get ready for bed. But yeah, hope you enjoyed, guys. Nice chatting to you as always. Nice to hear about your day as well. And yeah, nice to chat. Catch up a little bit, boom or bust. I'll catch you in the next live stream, probably for the speaker test of this amplifier, piece of crap, just to show you it working on a sub, and also for, I've got a few bits to repair actually, I've got a few fun bits to repair. I've got a little mains amp, got something else to plug into the mains that might explode, got a Audison that's a bit of a weird one. Yeah, lots of interesting stuff coming up to repair. So guys, take it easy, have a great evening, and I'll see you next time.